In finite element methodology, the basic steps are available for solving the problem. So we can segregate as like key idea with the different steps. Okay, so the key idea started with the step 1. What is step 1? Yes, solution for field variable. Field variable is the dependent variable. Okay, so y is equal to mx plus c. Mx plus c is the independent variable, y is the dependent variable. So in straight line equation, the field variable or dependent variable is y. So solution for field variable satisfying both boundary conditions and differential equations are unknown. Here, what is boundary condition? Here you see some elliptical shape available. What is boundary conditions? Which has this much of length, this much of width. These kind of constraints has, and also inside particles or have the specific volume, specific temperature. The micro constitution values are like, okay, so that the every engineer should aware about constraints. Those constraints are called as boundary conditions in engineering problem. So boundary conditions are constraints necessary for the solution of a boundary value problem. So boundary conditions are important. After that, differential equations. In our previous slide, I told about what is partial differential equation. How can we solve that partial differential equation with the partial derivatives explained. So the differential equations are also important. So solution for field variable that satisfying both boundary conditions and differential equations. The important thing is those are unknown. It may be unknown. Okay, this is the initial step. We begin with the assumed trial solution selected based on boundary conditions satisfied. Here I have another question. What is meant by trial solution? Here trial means a test of performance. For example, if you are consider your bike, you may check whether the bike engine gives the mileage or not, or the punctures, I mean tires are having proper functions. Likewise, you test the performance, so that you may regularly perform the trial and error experiments with that engine petrol level and then the air level. Likewise, you may perform the lot of trial experiments. So this FEM finite element method initial step begin with assumed trial solution selected based on boundary conditions to be satisfied. This is the step 1. And then step 2. After step 1, we can move to step 2, which is assumed trial solution. What I told in previous step, the tire puncture, oil level is maintained. So those are the assumed trial solution. Does not satisfy the differential equation. So developed mathematical model is not satisfied with the assumed trial solution, means we can closely and leaves the domain residual. Domain residual means some errors occurs with that elements. The petrol indicator is wrong, or air is not maintained 32, but it may be 31. I can accept and I can drive, so that we can leave the very small errors that are available with our daily functions. The same thing we can do with that finite element methodology also. Here I consider the word domain residual, which is the error that is available with our developed mathematical model of finite element methodology. Here the domain residual is the deviation occurred in differential equation satisfaction. According to finite element methodology, the domain residual is the deviation between the developed mathematical model and the real life problem. So which is the assumed trial solution, which is not satisfy, means we can with the differential equation closely means. Here you see lot of graphs available. If I consider the blue color continuous line is the original line, but other 3 lines are deviated from this original line, so that there are lot of deviations available. If the deviation is smaller manner, means I can accept the solution, but if deviates larger, means I can't able to accept the solution. So that these are all the things I studied with the step 2 of finite element methodology. And then step 3. What is step 3? Yes, domain residual varies from point to point. If I consider the domain is the large structure, means inside of that structure there are n number of points available, so that there are lot of deviations available. As per previous slide, there are lot of deviations available. Deviations means a domain residual available from point to point within the domain, but it cannot reduce to 0. So the errors, we can't reduce it to its 0. So some bias and noise, there should be a error available, so that we can't reduce the error to 0 within the considered domain. So we reduce the errors as very small to selected points. Here you see the n number of points available. The error may vary with each and every individual points. If it very small means we can neglect. Okay, so we can reduce the residual, but we can't eliminate. So we reduce the residual as very small to selected points in domain. Other hand, for entire domain. Finally, the weighted sum of the domain residual for entire domain is 0. Likewise, we considered. So after step 3, in step 3, all the things are getting too closer to 0, but not a 0, we won't bother. Okay, shall we move to other step as a total elements or total domain analysis? And then step 4, we came to accuracy of the developed model. Here the accuracy of the assumed trial solution improved by adding higher order terms in the equation, but it creates the problem in computation because it creates the computation time. So n number of terms available with the single mathematical model means which may create the problem in computation time. So single trial solution for single element from the entire domain is not a difficult task. Therefore, discretize the domain into several segments, each valid within a segment, which is called the finite element. So discretization is to be carried out in the finite element methodology for this reason. Okay, we can reduce the error, we can reduce the domain residual, and also we can split the total domain into several segments, each elements valid within a single element, which is known as finite element. Okay, so from this we can get the good solution. After that we can move to step 5. In step 5 there is trial functions used in each segment. Here you see, if I have the huge segment means we can separate it into a number of segments, so that trial functions used in each segment of domain is called element level shape functions. These shape functions, here you see the circular element and the triangular element available. So those are have different shape functions. So these shape function are interpolate the value of field variable. Already what is field variable I defined with the dependent variable at an interior point called nodes on the element. Already you know about what is nodes. Okay, so these are all the things I considered in step 5 as a shape function. Here you see the triangular element I considered, which is the shape. How can I move the next level of the total bigger domain? Yes, here you see I can move the element as like blue line from the rectangular nodes. I can move from this, I can move the element from one point to another point, or copy the element from one point to another point. From this I can make the solution. So after 5th step I can move to 6th. Here what I perform into the 6th step? Yes, compute sum of domain residual for each individual element and summed up overall elements with the shape functions. Already I told about what are all the shape functions available, the square, triangle, likewise lot of shape functions are available. Here you see the triangular functions, parallelogram functions and curved functions are available. So we can sum up overall the elements with the shape function to obtain the weighted sum of entire this Q domain with the aid of shape functions. After that, I can get the entire domain with the segmented elements. These are all the things we can perform at the step 6. After that, we can move to step 7. In that, the same shape function for entire domain is difficult, because if I consider the curvilinear shape, the curvilinear shape means I can't utilize. Yes, here you see the elliptical shape available. In that elliptical shape, I can't utilize the same square function for all the area. So I may utilize the different elements for different area within the same domain. So the same shape function utilization is the difficult task. So every software, for example, if I consider the ANSYS means the priori characteristics matrix are available for several types of element available with this software. So the user can select the variety of elements with respect to boundary condition of the object. From this he can fill up the entire domain with the different